Okay, now what we are going to do is we are going to fit our k-means algorithm into this. So let's write this section as fitting our model. Okay, create out some empty cells as well, and then from scikit-learn dot cluster we are going to import k-means. Okay, over here you can see that we have k-means plus plus and k-means. We are going to use k-means. Okay, k-means plus plus, we use it where we have this problem of random initialization. We are going to talk about it quite later, but just know that we use k-means plus plus as just for a plus point. We use k-means plus plus when we have this random initialization problem. Okay, we are going to go much deeper into that somewhere in the course. Okay, let's jump into k-means, and then we have k-means is equal to, let's call out k-means, create an object for that class. We are going to set n cluster. Okay, as of now I can see that we have one, two, we have few clusters. Let's set 4. As of now, let's set 4. Okay, and what we are going to do is k-means dot fit, and we are going to pass x. That's it. We have this, that is n cluster 4. That's how easily you can fit out your model, by creating an object and just fitting it out. Now let's set y k-means. Okay, and set k-means dot predict, and we are going to pass x. Oops. k-means k-means. Okay, so we have all the y k-means value. Okay, these are the, basically these are the clusters. Okay, these are the different clusters ranging from 0, 1 to 3, where it specifically starts up with. Now what I'll do is I will plot out this figure. Now that I have fitted out our model, I have seen out how it looks. I am basically going to do the same thing. I'm going to plot it out. Okay, plot this figure and change, save the color based on the centers, the clusters are defined by, and then plot out the centers, right? So I'm going to take this code, paste it out over here. We have this. Okay, the next thing that I'm going to do is I'm going to set s is 10 is fine. The next thing is, let's say c, the color mapping, it will k-means based on. Okay, you see we have these different colors. That's specifically what we eventually needed, right? And the next thing is, let's try to find out the clusters. Okay, for finding out the clusters we have this, that is to find out the centers, we have this form code k-means dot cluster centers, and that what gives me the centers. Okay, these are the centers, 4 centers. These are the x for the x-axis, and this is for the y-axis, and we have to do exactly the same thing what I have done over here. So I am going to copy this code, paste it over here, and rather than using x over here, I'm going to paste centers and gain center. And you can set the color of this. I'm going to set it as black. So you see we have these 4 dots. These are the centers of the clusters. Okay, and now what we can do is we can have it on the same plane. Paste it. Okay, same. And if you want to do, let's write alpha is equal to 0.5. Okay, it gives me quite a small shade. Let's change s equals to 10 to s equals to uh, 200. It gives me a better picture, right? So over here we can see that we have one cluster over here. Okay, I think this black dot is not actually very much visible, but yeah, we have a black dot over here, and we have a black center over here, and we have a center over here. So we can say that we are able to find four clusters, but just by seeing at the figure, you can say that k equals to 4 is not an optimal value for a solution, right? So we should be needing a way by which we can find out what should be the exact value of k. For that, we have the elbow method. As we have discussed in the theory lectures, elbow method, what we are going to find out is we are going to find out the inertia, okay, the differences of each and every cluster for each and every value of k.